friend, this is a Puja tutorial, and today Puja tutorial is going to given you a concept of set. And in my previous classes I have learned you about the set and what is the definition of set and how we represent that and what is the kind of the set in exercise number 1.1 and 1.2. Today I am going to start the exercise number 1.3 of NCERT books of 11th class maths. Okay, then let's start. In this chapter, first of all, we will discuss about the different type of set, like as some subset, power set, universal sets, and also we will discuss here about the interval, which type of interval you may have seen in a mathematics and use here. We will also learn here. Okay, and first is a subset. Then what is a subset? Actually this is a very important for understanding of the set. Then what is a subset? And it is very important property. Then subset. Okay. Subset. Subset is when we will set to if you consider a two set. Let us suppose A is one set and B is one set. Then if every element of A, let us suppose 1 and 2 is the element of A and 1, 2, 3 is the element of B. Then if every element of A is also element of B, then we can say in another way that A is a subset of B. And this is a symbol we represent for a subset. Then, and if you have to say that this is not a subset of them, then you will represent like this. This is the notion of the subset. Then actually you have already know about impetition. And in another way, the phi is called impetition. This is what is this? This is a phi. And we say that this is a impetition. And you know that which one is impetition? Impetition set is that type of set having no element. Then the phi, we denote that set by a phi. Then let us suppose that A is equal to 1 and 2. Then phi is also a subset of B. Why? Because phi is what? What is means it having no element. Then every set is also a subset of phi and also is a subset of itself. Like as subset AB is also a subset of it. Then you have to remember this. Okay. Now my next one is a power set. Actually, what is a power set? Then okay, first by discussing about the power set, first we will discuss here about the superset and proper set. Then let us suppose that A is equal to 1 and 2 and B is equal to 1, 2 and 3. Here A is the subset of B. It's clear? Crystal clear? It is crystal clear here that A is the subset of B. But A is not equal to B. Because you know by the definition of the equal of the set, then every element of A is also an element of B, then they will be equal. That's why here A is not equal to B. Then what we will say? We will say here that B is the superset of A. And also we consider A is the proper set of B. Then this is the concept of the proper set and superset. Okay. Now my next one is a power set. Actually, what is the power set? Power set is the collection of all those sets, collection of all those elements that is the subset of that set. Like as you can see here that 1 and 2. Then what would be the power set? Power set will be 5, because 5 is the subset of also I 1, 2 and 1, 2, because every set is the subset of its set. Then the collection of all those subset of A will be a power set of that. Then this is a notion of the power set. Now one thing is very important is here. Then what is the element would be a power set? How much element? How much will be an element of the power set? Then it is very clear here. Then how much element you have in a set A. If 2n means we will put here n. N is what? N is the element of n. Whereas n is the element of Then this is a notion of the how much element, like as you can see here, number of power set of A. How much element of A is 2. Then if we will put here 2, then the number will be 4. And you can see here, this is very crystal clear here that 1, 2, 3, 4. 4 is the how much element in proper set A? 1, 2, 3, 4. This is a power set. Then this is a power set. Then this is a different. This is a notion of the power set. Okay. Then okay. And next one is what is the universal set? You know that it appears from a name that universal. And what is a universal? Actually, universal means what? Universal means the set of the collection of every set, means all set that belongs to that context. Like as let us suppose A is equal to set of days. Then how much the element will be in our universal set? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Why? Because this is the universal set of the days. And how many days in a week? 7 days. That's why what would be the universal set? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Then this is a notion of the universal set. And universal set if you are going to represent a pictorial representation of the universal set, then you can use this as a D set. This is a pictorial representation of the universal set. Okay? And always be and remember, whenever you are denoting a universal, then it will be in a capital letter of the English alphabet. Then this is a notion of the subset for universal set, power set, and proper set, and superset. Okay, then I think that you have understood the all types of set here. Now, my next one is that is given in this chapter is an interval. Actually, what is the interval? Interval is what? Interval means what? Interval means antaral, means like as you are going there 2 and 5. Then how many numbers will be in interval? 2 and 5. Then how much number natural seen in this number? How much? How many? 2, 3, 4, 5. Why? Because the interval of naturals. That's why 4, 3, 2, 5. All belongs here. But there are 4 kinds of interval. First one is, you will see in mathematics, there are 4 kinds of interval. First one is open interval. Open interval. Actually, what is the open interval? Open interval means like as this is the interval. Okay? Here I write here 1 and I write here 5. Then in between this interval, how many naturals lie? 2, 3, 4. 2, 3, 4. Okay. Between this one and this one, how many naturals will lie? 2, 3, 4. When we exclude 1 and 5, then it will be a open interval. Means what is a open interval? If AB belongs to real number, then collection of all those y such that A will be greater than y and y will be less than b. Then here we are excluding A and b. Then what will be the open interval? Open interval. We denote the open interval with from a small bracket, and between 1 and 5, between 1 and 5, 2, 3, 4 will be elements include here. Then this is your open interval. Open interval means excluding of that element. It is called a open interval, and we represent a open interval by a small bracket. Okay. Then this is the open interval. Next one is a closed interval. Closed interval is a connection if closed interval. Closed interval means what? Closed interval means what? If there are 2 points in a number system like as here 1 and 8, then when we include 1 and 8 also, how much naturals will lie between this and this? And 1, 2, 3, 4, 5, 6, 7, 8. Then we can see in another way that this one is closed interval. Closed interval is also represented by a big bracket. Okay? Then this bracket is represented to closed interval. Now, next one is open close. Open close. Open close. Open close means open. Means first we will denote here open and then close. Close, how we will represent this one. This is called a open close. Open close means collection of all those y such that This is the open. A is less than y and y is less than equal to b. Means 1 and 5. This is the open close. Then how many naturals will lie between in our open close interval? We exclude 1 here. Then 2, 3, 4 and include 5 here. Because this is open close interval. And this is called it is a notion of the open close interval. And next one is a close open interval. And like as the same close open interval also, close open interval, close. First one is close and second is open. Okay, and collection of all those y such that a here a is closed, that y less than equal to y and y less than b. Then this is the notion of the closed open interval. Like as you can take an example that 1 and 5, then 1 and 5, and 1, 2, 3, 4. These are the natural line between this interval. Then this is the concept of the close open, open close and close open interval. And I think that you have understood all the interval in a crystal manner. Okay, now let us start the question answer of this chapter and practice it. Okay. This is exercise number 1.3. In this exercise, first one is 2, 3, 4. You have to consider here which one is subset or which one is not. And 2, 3, 4 it will be a subset of here. Yes. Why? Because 2, 3, 4 is also an element of this set. That's why we will put here this symbol. Whereas ABC is not an element of this set. That's why we will consider here this symbol. Okay. Next one is, now you have to practice more and more at home and solve these questions accordingly. Okay. Now next one is, which one is true and which one is false. And you can see here that AB. Okay. AB is also an element of this set. That's why we will, this is a false. We will leave here. We will represent here this symbol. Okay. Next one is AE. AE. Okay. AE. Okay. Is a subset of collection of all those X is a vowel of English alphabet. Which one? Which vowels is in our alphabet? A, E, I, O, U. Then it is crystal clear here that AE is also an element of A, E, I, O, U. That's why this is true. Next one is 1, 2, 3. Is the subset of 1, 3, 5? No. Because 1, 2, 3 is not an element of this set. That's why this is not a subset of this. A is the subset of this one. Yes, of course. Because A is also an element of this set. That's why this is a subset of this set. A belongs to, here what is this? This is a belongs to. This one is the belongs to this. And now it is very clear here that you have understood all the topic that is related to subset. Now next one is A is equal to 1, 2. This is which one is correct and which one is not correct. We have to identify here. Then 3, 4. Okay. Then this is true. 3, 4 is also a subset of A. Also belongs to A. It is true. Also no, because only on this one. Okay, sorry. This one is the subset of A. This one is not belongs to, because this is a subset of A. This one is not a subset of A. That's why this is 1 belongs to 1. True. 1 is subset of A. True. 1 to 5 is a subset of A. True. 5 is a subset of A. True. But this is not true, because this is a singleton set. When a set having one element is called a singleton set. Like as this is what? This is a singleton set having one element. But 5 has no element. That's why 5 is empty set. Okay? Now, my next one is write down all the subset of the set. Like as A. Let us suppose A is equal to A. And how much element of A? How much subset of A? You can write here. 5, because 5 is the subset of every set. And second one is A. Okay? Then this is a subset of A. Like as you can write here this one and this one and this one also. My next one is how many elements of power set of A? If A is equal to 5. And you know that power set number of power set of A would be how many elements in a empty set out of 5? 0 element. That's why this one is 1. And you know that every set is a subset of itself. That's why this is having a 1 element. That's why the answer will be 1. Write down the interval O. You know that about I have already given you a notion about the interval. Now let's do a practice here. How we represent an interval? Okay. Then collection of all those x such that x belongs to R. Means x belongs to reals. And -4 is less than x and the x is less than equal to 6. Means here 4 is excluded but 6 is included. Means -3, -2, -1, 0, 1, 2, 3, 4, 5 and real element of this. Okay? I think that you have understood the notion of what is this? This is a this is a open. This is a open close interval. Okay. This is a open close interval. Okay. Now, what is this? Question number 6. Question number 2 of what? Question number 6. Second question of question number 6. What is written here? It is, you know that by the definition of the open interval, here 12 and -10 is excluded. That's why what will be a real? Which reals will be lie here? -11 only. Why? Because here 12 minus 12 is also excluded and minus 10 is also excluded. Okay? I think that you have understood it very well. Now you have to do a practice at home. Now, my next one is write following interval in a set builder form. Then this is an open interval. Then you can say here collection of all those x such that minus 3 is less than x and x is less than. This is a collection of all those x such that minus 3 is less than x and x is. And I think that you have understood. Sorry. This is a reals. That's why collection of all those x belongs to reals and minus 3 is less than x and x is less than. Then you can represent this one in such a way in our set builder form. Okay, my next one is, next question is, it is in open interval and it is a natural. That's why you can see here collection of all those x such that x belongs to a naturals and 6 is less than equal to x and x is less than equal to y. And this is the set form and you convert it in such a way. I think that you have understood all the concept of closed and open interval. Now, my next one is, what is the universal set and would you propose it of the following? The set of right angle triangle. The set of right angle triangle and the set of isosceles triangles. Then which one would be a universal set? Means triangle. Triangle will be a universal set because in a context of a right angle triangle, the set of triangle would be a universal set. Okay. Now, my next and last question of this chapter is, given the set A is equal to this one and B is equal to this one and C is equal to this one, which one is following may be considered a universal set? All will be considered as a universal set. Then you can make a element. And which one element will be? 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This will be considered as a universal set. Okay, right here. Then I think that you have understood the exercise number 1.3 in crystal clear manner